Hi everyone. In this video, I want to talk about when we have an expression that involves a fraction, or you can think of this as a rational expression. Basically, if we have some kind of variable in the denominator, I want to talk about when we have to place restrictions on that variable. Okay? So in math, one of the main rules that I hope you learned from this class is that we can never divide by 0, okay? So so I have some number a, and if we divide it by 0, this is undefined, okay? So the denominator in any rational expression can never be equal to 0. All right. So if we have some expression where we have a variable in the denominator, we have to check to make sure that any value that would make the denominator equal to 0 is excluded. Okay. So let's take a look at a few examples here. We want to find all excluded values for these given expressions. So here we have x over x minus 2. Okay. So if we're looking for all of the values that would make the denominator equal to 0, and we're wanting to exclude them, the way to find this is actually just to take the denominator and set it equal to 0. So we're going to set the denominator equal to 0. Okay? So if we set the denominator equal to 0, remember the denominator is on the bottom, okay? So we're going to set the denominator equal to 0. We have x minus 2 is equal to 0. We can add 2 to both sides, and we get x is equal to 2. So we have an excluded value of x equals 2. Okay, this is our excluded value, x equals 2. So really, this function here, x over x minus 2, is going to be defined for any number that we plug into it except for x equals 2. Because if we plug in x equals 2, we're going to get 2 minus 2 is equal to 0, and therefore we can't do that because we can't divide by 0. Okay, so let's take a look at some more interesting examples. Here we have t squared minus 2t minus 48 over t squared minus 4. Now, one thing I want to say up front is that you really only have to focus on the denominator here. We'll see some examples where it's more obvious that maybe we want to try to cancel things. But the truth is that you want to find what the excluded values are before you do any manipulating to the equation, before you try to cancel anything out, okay? So in this example here, the only thing we have to worry about is the denominator. We can effectively just leave the numerator alone. So if we set the denominator equal to 0, we can get t squared minus 4 is equal to 0. Okay, and here we have a difference of squares. Okay, we have a difference of squares. So remember our formula for a difference of squares. If we have a squared minus b squared, this is equal to a plus b times a minus b. Okay, so here, instead of a difference of squares, the square root of t squared is t. So this is the same thing as t plus the square root of 4, which is 2, times t minus 2. And this is equal to 0. So what we do is we find out when each of these is equal to 0. So we set t plus 2 equal to 0. Okay, cancel, and we get that t is equal to minus 2. And we also set t minus 2 equal to 0. We can add 2 to both sides, and we get t equals 2. So both of these are going to be excluded values. Sorry. So both t equals negative 2 and t equals 2 are excluded values. Let's look here at y plus 5 over y squared minus 25. So if we set the denominator equal to 0, we get y squared minus 25 is equal to 0. And once again here, we have a difference of squares. And the square root of y squared is just y. So we'll have y be plus the square root of 25, which is 5. So y minus 5 is equal to 0. What I was mentioning earlier was we have to check this before we do any canceling. We can then rewrite this as y plus 5 over y plus 5 times y minus 5. If you rewrite it like this, it might be tempting to go ahead and cancel these, and then you only have to worry about y minus 5. That is not true. You have to check the excluded values before you do any of that, okay? So you're going to check this before you cancel anything. Now, you may still cancel things in the end because you want to do more work on the expression. However, the excluded values are going to come from how the problem is initially written, okay? So here we have to find when y plus 5 times y minus 5 is equal to 0. So just like before, we'll set each of these equal to 0. So if we have y plus 5 is equal to 0, we're going to get that y is equal to negative 5, and y minus 5 equals 0 is going to give us y equals 5. So these are both our excluded values. Okay? So let's do one more. Here we have v minus 1 over v squared minus 2v plus 1. Okay? So if we want to factor v squared minus 2v plus 1 and then set it equal to 0. So we want to find two numbers that multiply together to give us 1 and add together to give us negative 2. I'm thinking negative 1 and negative 1. So this is equal to v minus 1 over v minus 1 times v minus 1, or v minus 1 over v minus 1 squared. Okay? So we can set v minus 1 squared equal to 0. And we really only have to worry about one instance of v minus 1. You could think of this as v minus 1 times v minus 1, but there's no point in checking it twice. So really, we just have to consider v minus 1 is equal to 0. We can add 1 to both sides, and we get v is equal to 1. So this would be our excluded value.